Our project is concerned with optimizing protocols for engineering certain cell types or tissues in a dish. There are existing protocols to make many kinds of cells in a laboratory nowadays that typically involve multiple steps of treating cells with complex cocktails of molecules that are in some way inspired by developmental biology and what we know about the development of cells in a living organism. But coming up with such protocols is a very cumbersome process. It's time intensive and costly.
My team will generate the experimental data that will be then used by Florian and his team to train a machine learning model. Specifically, we will take stem cells from the blood, differentiate them to red blood cells progenitor, and then use next generation sequencing to profile the chromatin status of these cells.
So we have an idea in which we borrow concepts from computer science and machine learning to make this process of finding new protocols more efficient and effective. We are making use of genomics technologies to take measurements of the cells as they go through the differentiation process, and we need to be able to quickly look at them, assess the progress, so that we can decide on the next steps to take. So this is really the key challenge, to make these decisions in a very short time frame.
I think this is the beauty of this project. We don't use a selection process for differentiation, but we try different approaches, and then we let the machine learning model to tell us which one worked the best. So this project is important for us because it represents another evidence or another attempt to prove that epigenetics and chromatin can be used to predict the status of the cells and to predict the different potential of a lineage.
So the main applications would be to improve protocols for use in regenerative medicine, in which the goal is to replace damaged or diseased tissues. Current protocols exist but are often not effective enough at producing these cells in high enough numbers. But there are also potential applications in disease modeling for research purposes. Or one of my ultimate goals would be to reprogram cancer cells to a less malignant state. So I'm hoping that this will be one of the first steps in this process.
So one could use this model to take leukemic cells and find the best way to bring this proliferating cell into a terminally differentiated status. And that would actually terminate the cancer status of a cell.